Hi there. This video is an exam paper walkthrough of the AQA GCSE Mathematics Foundation Tier Paper 1 from summer 2023. This paper is worth 80 marks in total, and this is the third video of 4. It will focus on questions 13 to 18, which account for 18 of these marks. AQA Paper 1s are non-calculator, so a calculator cannot be used. A little disclaimer: there may be more than one way to answer a question. The methods shown in this video are not the only way some mathematical skills can be applied. Okay, let's get started. Question 13. Students choose juice with their school meal in the ratio orange to apple to lime is equal to 5 to 2 to 3. So we've got orange, apple and lime. I just need to make it clear to myself that that's what each part of that ratio relates to. It wants us to complete the bar chart. So we have a bar for orange, we have a bar for apple, we don't have a bar for lime. So we need to figure out how tall our bar for lime is. It isn't as simple as just drawing the bar up to 3, because what you'll notice is the orange bar goes up to 20. So actually 20 orange juice. The apple bar goes up to 8, so 8 apple juice. So the ratio for the parts of the ratio for orange has changed from 5 to 20, and the parts of the ratio for apple juice has changed from 2 to 8. So we need to see what the scale factor is that they've changed by. So to get from 5 to 20, we would multiply by 4, and to get from 2 to 8, we would multiply by 4. So we can assume then that if we multiply the parts of the ratio for lime juice by 4, that will tell us how tall to make our bar. So 3 times 4 is 12. So we're going to draw a bar up to 12 on that left-hand axis there for the number of students. Now we need to make sure they've left a gap between orange and apple, so we need to leave the same gap. So if we make a mark up where 12 is, and then we can continue to draw the bar. I would recommend drawing the bar in pencil, just in case you make a mistake. You need to rub it out to make it nice and clear for the examiner which is your correct line if you do need to redraw it. Question 14. Here is some data about people visiting a gym 1 week. So we've got members and guests. We've got the percentage of all visitors. So 64% of all visitors were members, 36% were guests. We've got the mean number of hours they visited for. So in 1 week, members had visited for an average 4 hours and guests visited for an average 2.5 hours. And then we have the range of number of hours visited. So this tells us how consistent the data is. So the members have a range of 6 and the guests have a range of 8. And then it says compare the data for the members with the data for the guests, make 3 comparisons, and it gives us spaces to do just that, to make those 3 comparisons. So we've got 3 statistical values, so we're going to compare those values for members and guests in each of those 3 things. So comparison 1, let's do the percentage of all visitors. So 64% were members, 36% were guests. So we can say that a higher percentage of members visited in 1 week than guests. So a higher percentage of members visited in 1 week than guests. Okay, so we've done that one. Now we're going to compare the mean number of hours they visited for. So that's the average number of hours. So on average, members visited for 4 hours that week, and then guests visited on average for 2.5 hours in that week. So the members have a higher mean. So on average, they visited longer in that week. So on average, members visited the gym more in 1 week than guests. Okay, so that's that one. And then the last one to compare is the range. So I said that the range was the spread of the data, the consistency. So the bigger the range, the more inconsistent the data. The smaller the range, the more consistent. So members have a range of 6, guests have a range of 8. So members have a lower range, which means they were more consistent with how long they attended the gym for that week, whereas the guests, the data was a little bit more inconsistent. So we can say members were more consistent in the number of hours they visited the gym in 1 week compared to guests because their range was smaller. So members were more consistent because their range was lower. There we go. Question 15. A large rectangle has a rectangular hole cut out. So this is our large rectangle, 4 centimetres by 5 centimetres. This is the rectangle that's been cut out, 2 centimetres by 3 centimetres. It tells us it's not drawn accurately, so we can't take any measurements from the diagram to help us. It asks us to work out the percentage of the large rectangle that is shaded. So we're trying to find out what percentage of this large rectangle is the grey area. It's a 3-mark question. So to figure this out, we need to find the area of the large rectangle first without anything cut out. So the large rectangle, to find the area of a rectangle, we do length times width. So 4 times 5, which is 20 centimetres squared. So the total area of the large rectangle is 20 centimetres squared. However, they're going to cut out that smaller rectangle. So let's find the area of the small rectangle, which is 2 times 3, which is 6 centimetres squared. So when we cut that small rectangle out, we remove the area of it from the area of the large rectangle. So we're going to take those areas away. So the grey area, the shaded area, is 14 centimetres squared in total. However, they want that as a percentage of the large rectangle. So we have got 14 out of the total 20 centimetres squared available to us. So 14 out of 20 is a fraction, but we want it as a percentage, so we need to make that into a fraction over 100. To get 20 to 100, we scale it up, we multiply by 5 because there are 5 20s in 100. So we have to do the same to the top of the fraction, to the numerator. 14 times 5, 10 times 5 is 50, 4 times 5 is 20, so that's 70 out of 100, which, because it's out of 100 and a percentage is out of 100, we can just read off the top value. So the answer is 70%. Question 16. Liz travels 18 miles in 20 minutes. Work out her average speed in miles per hour. So we want the average speed in miles per hour. We've got the distance in miles, but we have the time in minutes. So we need to convert those minutes into hours for our calculation. So 20 minutes is 20 out of 60 minutes in an hour. And then if we simplify that, we get 2/6. I'm going to leave it like that for now because I know that a fraction with 6 on the denominator isn't going to give me a nice integer value to work with. It's going to be a recurring decimal. I'm just going to leave it like that for now. So it's 2/6 of an hour, which is, we could simplify to 1/3 of an hour if we want, but again, it's a recurring decimal. So we are dealing with speed, distance and time. So we're looking for the speed, so we want to do the distance divided by the time. So we are doing 18 divided by the time in hours, don't forget, miles per hour. So it has to be this value here that we're using because we've converted from minutes to hours. So we're doing 18 divided by 1/3. Here I'm doing a division with fractions. So I'm going to write 18 as a fraction over 1. Remember, you can do that for any integer value. And when we're dividing, I'm going to keep 18 over 1 as it is, and then I'm going to write the reciprocal of 1/3. To write the reciprocal of 1/3, I'm going to flip it upside down. And then we change it to a multiply. Using the reciprocal means that division becomes a multiply, okay? Because division and multiplication are inverses. Now on the top we're doing 18 times 3, and on the bottom 1 times 1, which is 1. 18 multiplied by 3, however you feel like doing that, add 18 3 times, or 3 times 10 is 30, 3 times 8 is 24, add those together gives me 54. 54 over 1, 54 divided by 1 is just 54. So Liz is travelling 18 miles in 20 minutes and her average speed is 54 miles per hour. Question 17. ABC, so ABC, this straight line here, BD, BD, and BE, BE are straight lines. Angle EBD equals 5 times angle ABE. So angle EBD, EBD, so that is angle EBD. It's 5 times angle ABE. Well, ABE is this angle here. So I'm going to call that angle X. And if EBD, the angle, is 5 times that, I'm going to label that as 5X. Then it says DBC, so DBC is 3 times the angle AB. Well, we've already labelled that X. If it's 3 times X, I'm going to label that as 3X. Then it says work out the size of angle EBD. So EBD, we're wanting the size of this angle. However, we don't know what that X value is yet. We're dealing with angles on a straight line. Angles on a straight line add to 180. There we go. So X add 5X add 3X should equal 180. So I'm going to form an equation. X add 5X add 3X should equal 180. So we've got 1X plus 5X, which is 6X, plus 3X, which is 9X. At this point, we've got a one-step equation. To find X, I'm going to divide both sides by 9. It's the inverse of multiplying by 9, and this is 9 multiplied by X. 180 divided by 9, well, 18 divided by 9 is 2, so 180 divided by 9 should be 20. Now, we haven't finished. They want the size of angle EBD. We know X is 20, so we need to find out the value EBD. Well, if X is 20, 5X is 5 times 20, which is 100. So angle EBD is 100 degrees. Question 18. 2 prime numbers are multiplied together. The answer is an even number between 50 and 60. Complete the calculation. So these two boxes are going to be our 2 prime numbers because they're being multiplied. And then they equal this value, which is an even number between 50 and 60. All right, so let's first of all start thinking about our prime numbers. Okay, so our prime numbers, let's start with 2, 3, 5, 7, 11, 13, 17, 19. Okay, so I've listed the first 3, 6, the first 8 prime numbers. Now, what we need to recognise here is if we want this answer to be even, one of these 2 numbers has to be even. That's the rule. An even number multiplied by an odd is going to be an even multiplied by an even is going to be even. So we need at least one of them to be even. Now there is actually only one even prime number, and that's 2. So we're going to use 2 in this calculation. So 2 multiplied by another prime number is going to give us a number between 50 and 60. Now, I only went up to 19. 2 times 19, well, 2 times 10 is 20. 2 times 9 is 18. That's 38. That's not a value between 50 and 60. So I'm going to have to keep going up in my prime numbers until I get a value that when multiplied by 2, when doubled, gives me an answer between 50 and 60. So my next prime number is 23. My next prime number is 29. Let's check. Double 29, what does that give me? Because I know double 23 is 46. So 2 times 20 is 40. 2 times 9 is 18. 40 plus 18 is 58. 58 is a value between 50 and 60. So this is the other prime number that I'm going to put there. And then the answer that I got when I multiplied them together, the product is going to go in the answer box there.